Welcome to this Scikit machine learning tool tutorial. In this video, I'll demonstrate how we use Hist gradient boosting regressor to perform a multivariable regression task on real-world agricultural data. Our goal is to predict crop yield based on multi-input features using an efficient and scalable gradient boosting method. Hist gradient boosting is particularly powerful for large datasets, and we'll see how it improves training speed and predictive accuracy. The dataset we use comes from Food and Agriculture Organization of the United Nations. It contains about 28,000 rows and 7 columns of agricultural production data, where each record includes both environmental and geographical factors related to crop cultivation. The input features include variables like country area, crop item, production quantity, and other encoded factors. Our target variable is HGHA yield, which measures the agricultural yield in hectogram per hectare. Predicting yield based on these diverse inputs provides a good example of multivariable regression challenge. And before training the machine learning model, we have to prepare the data properly. For example, some columns such as item and area were originally stored as text strings. Machine learning models require numerical inputs, so we encoded these categorical variables into numerical values. This encoding ensures that the model can efficiently process the data during training. This is an example of encoded crop yield dataset. As we can see, the area and item columns are all encoded into integer values instead of text strings. This will guarantee our model trains with this dataset without any issues. With these multiple numerical input features, predicting crop yield becomes a multivariable regression problem. In traditional simple regression, we have only one feature predicting the target. But in multivariable regression, we model more complex relationships by using many features at once. In our case, the HGHA yield depends on multi-encoded features like crop type, area, and production variables. The Hist gradient boosting regressor that we will introduce next extends this idea beyond simple linear regression by learning nonlinear complex relationships between the input and the yields. Hist gradient boosting is an advanced version of gradient boosting that is optimized for speed and memory efficiency. It works by binning continuous features into discrete intervals, creating histograms, and finding the best splits based on these bins. For example, if a temperature feature ranges from 0 to 100 degrees Celsius, instead of considering every decimal value, the algorithm groups the range into bins like 0-10, 10-20, 20-30, and so on. This binning approach drastically reduces the computation needed at each split, making the model much faster, especially on large datasets like ours with over 28,000 samples. Another key advantage of Hist gradient boosting is that it can automatically handle missing values and scale efficiently to big data without needing a lot of manual tuning. And during training, each new decision tree focused on correcting the errors made by the previous tree, gradually improving the model's predictions. During training, the Hist gradient boosting regressor feeds on the training data, learning how different input features related to crop yield. Once trained, the model predicts the HGHA yield for the test samples. To evaluate performance, we calculate R-squared score, also known as the coefficient of determination. An R-squared value close to 1 means the model's prediction closely matches the true values, indicating strong predictive ability. This is our Scikit ML AI web interface. I will demonstrate how to use this web interface to implement Hist gradient boosting regression. We can add our project name here and the description here. On the data type drop-down list, we have 4 choices: tabular, image, text, and signal. We will choose tabular because our data is in CSV format. And we choose upload CSV and click this. And we choose this UDF encoded. Now we can see from the table overview, we have area and item columns encoded. And here, HGHA yield is our target, and the rest are our input features. On the target label, we choose the HGHA yield. And then we select machine learning algorithm. And for the class, we just choose our Hist gradient boosting regressor. It's on the bottom of this list. And for evaluation metric, we use R-square as we discussed before. And we click perform. And it takes only a few seconds to get a result. We can see our R-square result is 0.97. It's very close to 1, which means our model was able to predict the values with very high accuracy. And this plot does not apply to our task because we have multi-input features. This is great for one input feature and one target. And if we want to take a look of the more specific values, we can go to this table and scroll to the right. And we have y-test, which means it's the truth data from our dataset. And y-predict is the prediction data from our model. And this has been our tutorial for this Hist gradient boosting regressor project. Thanks for watching.